Next up, it's time to take a closer look at strings. So strings in Python are deceiving. On one hand, they're primitive values. They're not built up of some simpler type. They're easy to work with, like we've seen. We can input, concatenate, cast, print, whatever we need to do with those strings. But on the other hand, they're also considered objects, these complex types. In fact, strings end up working a lot like lists, with some important differences. Now, historically, in other languages, strings were considered lists of a simpler type of value, which are known as characters, or the char type. So strings were known as character strings, hence the name. Python did away with the char type, so strings became the basic building block for text. But that means that strings are built up out of smaller strings. So now strings are considered both primitive types and objects. This is probably easiest to see if we go straight to Python. So at our interactive Python terminal, we will say, make a new variable, a new string, and we'll say hello world. So I can say, what's the value of this variable? And it says hello world. I can ask, what's the length of this variable? Just like we can with a list. In this case, it says the length of that string is 11. I can ask, what's the length of the empty string? And that's 0. We can index a string. So I can, for example, say print hi at 0. And that prints the first character from our string. If I ask the value of high 5, in that case, it's the space between the two words, because we start at 0 for the H, ELLO, 1, 2, 3, 4, and then the space is index 5. We can use negative indexes, so I can say hi at -2. That's the second last value, which is the L in world. I can use slicing notation on strings to get substrings, so I can say hi from 1 to 4, and that's L. And I can combine them as well, so I can say things like hi from -4 to the end if I wanted to get the last 4 letters from my string. This also works on string literals, so I could say goodbye, and the range from 1 to 4, and that takes a substring from that string literal. Okay, so just like lists, we can access the individual elements. The indexes start at 0. The last index is the length of that list, or the length of that string, -1. Negative indexes work the same way, as do slices. We can use membership tests, so we can say, for example, is the letter E in our variable hi? And that's true, because there's an E in there. I can ask, is the letter Q in hi? And that's false, because there's no Q in hello world. This is useful, for example, if I wanted to say, is the substring .txt in filename.txt? And that's true, because that string contains that substring. And we can do traversals for strings the same way we would do with lists. So we can use for each loops and say, for C in my string hi, I will print C plus some exclamation marks. Now it goes through our string, and for each character at each index, takes that value and prints it out. So strings end up looking a lot like lists. We can do a lot of the same operations to lists as we would to strings. But the big difference between strings and lists is that strings are immutable. So mutable means things can be changed, which means for lists we can say something like list at 0 equals, and then give it a new value, and that will change the list without making a new list. When something is immutable, that means it can't be changed. So we're not allowed to mutate the individual elements of a string. So for example, if I said hi at 0, get some new letter, it says type error, string object does not support item assignment. You are not allowed to mutate strings. We have seen, for example, we can modify strings by concatenating them together. So what happens there? How does that work if things are immutable? So if I said, for example, x equals some text and y equals x, so we have an alias, so let us say x is y, they're both pointing at the same string. If I said x equals x plus exclamations, that ends up making a brand new string. So if I said x, it now has exclamations, but y does not. And x and y are now pointing at separate variables. So the idea here again, when we use concatenation, we create a brand new string and then assign that string to our original variable. So even though we had an alias between the variables x and y, the string that those two things were pointing at is immutable. So when we go to change one of them, we don't have to worry about the other changing. It ends up making a brand new string instead. And now that we've learned these new things about strings, let's put them to good use with a programming task. This task says, write a function that takes a string as an argument and returns the middle letter in that string. So we have two examples here. If we're given the string taco cat, which has 7 total letters, it returns the middle letter, the O here. If we are given a string like Python, which has 6 total letters, noting that there's 2 middle letters when we have an even number. In this case, it's rounding up and taking the latter of those 2 middle numbers. So according to this provided example, our code should just return H. So back in VS Code, let's make a new file for this one. We'll say strings.py. Now, before we solve this problem out, it might help us to design it a little. So just in comments, let's write out the words that we're given. We're given taco cat, and we're given the word Python. Now, since these are strings, they have indices for each one of the characters in that string. So we'll say 0, 1, 2, 3, 4, 5, 6. And similarly with Python, 0, 1, 2, 3, 4, 5. So with this first word, the length is equal to 7. And the middle letter, which is this O, is at index 3. So we'll say mid equals 3. With Python, the length equals 6. And our middle letter, now we have 2 middle letters, but again, our challenge told us to use the latter of the 2. In this case, is also 3. So mid equals 3. We could try some other words, perhaps something small like dog, which has a len of 3. And the middle letter there, 0, 1, 2. In that case, the mid is at index 1. Let's try a word with 4 letters, so we'll say dogs. So that's length equals 4. The indexes are 0, 1, 2, and 3. And the middle index, again noting we have 2, but taking the latter, is at index 2, so mid equals 2. So given some input string, we're also technically given the length of that string just implicitly by given the string itself. We're supposed to return the character at these numbers. So we've got the input number and the output number. So we've designed in our comments here an input to output mapping. So notice our output doesn't matter what the word is, only just how long the word is, and then we just find the spot in the word that we need to return. From these examples, we can also see that when we have an even number, the value we're returning looks to always be just half of that even number. So that's pretty easy. We just take the length and divide by 2. But what happens when it's an odd number? Well, 7 divided by 2 would give us 3.5, and there's no such thing as index 3.5, but we're looking for index 3, so perhaps we round down. Considering our other example, if we're given a string of length 3, 3 divided by 2 is 1.5, rounded down gives us index 1. So that does seem to hold. So in all 4 of these cases, if we take the length of the value, divide it by 2, and round down, we'll have the middle index. So that seems to be a good place to start. Once we've written the actual code, we can test it with more words to make sure it works in more general cases. But now that we have this, let's write our code. So we'll say def middle letter, given some string, I'll just call it a string. Now, that string already has a length. We don't have to do anything to give it one, but we want to use that length then to compute our middle index so that we can retrieve that middle letter. So we'll say middle index is equal to the length of our string divided by 2. But now, remember, if I use division, I'm going to end up with a floating point number, and indexes need to be integers. So I'm going to want to do integer division. As an added benefit of integer division, it also rounds down, so it gives us 7 divided by 2 is 3, and 3 divided by 2 is 1 when we're doing integer division. So that gives us everything we need, actually. We have our middle index, so let's return that from our string. So we'll say return a string at middle index. Notice this doesn't do anything to the string itself. It doesn't change the string in any way. It's just accessing a specific part. So let's make a main function so we can run this, def main, and this will just say print the middle letter of taco cat, and we'll print the middle letter of Python as well, our 2 given examples, to make sure our code works at least as expected there. We'll say main, save, and run our code. So Python strings.py. And we get the correct words. So that's great. We can test this with other inputs. So we saw print middle letter of dog should also be O, and print the middle letter of dogs should be G. And we get those correctly as well. We could try print the middle letter of just the word A, and that should just be itself, and that works. And maybe an edge case here. What happens if we say print the middle letter of an empty string? And then our code crashes. String index out of range. So walking through our code, we have an empty string that becomes a string. We check the length of that string, which is 0 because it's empty, and divide that by 2. 0 divided by 2 is 0. We store 0 in middle index, and then on the next line we say return a string at 0. Now, because this is an empty string, there is nothing at index 0 because there's nothing in the string at all, so we get string index is out of range. So to fix this, we could make sure that our string actually has a length, so we could say something like, if the len of a string is greater than 0, then do all of these things. And in the other case, this won't return or do anything, so if we save and run our code, we get none instead. So instead of crashing now, there's no middle letter in an empty string, which seems appropriate. We could put an else case in there that returns an empty string. Perhaps if this code is being used by something that expects a string to come out, then returning a none value could be a problem, so we could say else return the empty string. But now we're expanding on the task that we were given, so we'll call this complete. Next, for a slightly more difficult challenge, consider the following. Write a function that takes a string as an argument and returns a list of all the words in that string. So for example, given the string 1, 2, 3, 4, we'll return a list that has the words 1, 2, 3, and 4, each as separate elements in that list. I suppose I should mention this again is us rebuilding one of those wheels. This is a thing that you can do with strings in Python, which we'll cover after this. Back in VS Code, let's define a function, def parse words, that takes in some string. I'll call it S for short. And now we need to parse the words out of that string. Now before we dive in without knowing where we're going, let's try to design this solution a little bit. So let's start with just some sentence like, hello everyone, this is a sentence. Okay, put this in comments. Now if this were our sentence, our input sentence, how could we get, for example, just the first word? How could we get the second word? How could we separate all of the individual words? But now let's start with this first problem. How do we get just the first word from this sentence? If we want to make a small string from a larger string, that means we're making a substring or a slice from our original string. Now if we're taking the first word, obviously our start index would be the beginning, or we could just leave that blank. But then what would be the index for the end of that first word? Well, in that case, it would be the index of wherever the first space is. So if we're starting here, 0, 1, 2, 3, 4, 5, if we took a slice from 0 to 5, then that would be the first word. So the question is, how do we find the first space? Well, that sounds like a traversal. If we traverse through this string, checking each character as we go, and asking, is this a space? Is this a space? As soon as the answer is yes, then we found the first word. Then we can do something about removing that, slice it out, and then perhaps in some sort of loop we could repeat this. So if we wanted the second word, then we would find the next space. So traverse across this string again until we end up at another space. But now we can't use the beginning of a string as our first index. We want to have the previous space as our index. So we'll have to keep track of one space as we're going. Now if we repeat that, we'll take the next space, we'll grab the word between those two spaces, and then we'll repeat. We'll grab the next space, take the word between those two, find the next space, grab the word between those, etc., etc. We get all the way to the end, and notice there's no space at the end. So that sounds like a special case. We're going to have to manage that last word in a different way. But we'll deal with that when we get to it. So, step 1, we're given some input string. We want to find all of the spaces in that input string. So we'll say, for I in range to the len of s. Now in this case, I'm using a regular for loop instead of a for each loop because we're going to be doing substring slicing, which means we need the indices in order to do that. So very likely we'll want to know where we find the space, not just that it is a space. So as we're traversing across our string, at each index we'll ask, is this character a space? So we'll say if string, which is s, at the current index, which is I, if that's equal to just an empty space, then we found a break between words. So this is the basic traversal we need to do, but now what are we doing with that traversal? So the end result here is we want to end up with a list. We want to take the input string and separate the text in that input string, taking each chunk into a list. So we'll have to start with an empty result list and build that up one word at a time. So I'll just call this variable words and give it the value of an empty list to start. Then we find a space, that's the separation between words, so we're going to add that to this result list. So we'll say words.append, and then the thing we'll append is a substring of our original string. So we'll say from s between two indices. Now we have one index here, this I variable, and if we're traversing through this list and we found our first space, then that I variable is pointing to the end of that string. If we continued on, we found the next space, that's the end of the next word that we found. So I should go at the end of our string here. Notice we also don't want the space in there, so a substring up until, but not including the character that is the space itself. And for now, we'll leave the beginning blank and we'll see what happens. It'll give us some sense on how to fix that. Let's return what we found and test out what we got so far. So say down in main, print, parse words, and I'll use this sentence here. There we go. Save. Python strings.py. Now looking at the words that actually came out, we got hello, which is the first word, so far so good. Then we got hello everyone, which is the next word, but we also included everything from the beginning. And then we got hello everyone this, which includes the next word, but again, all this chaff from the beginning of our string. And it seems to be continuing on. This is and it didn't get the last word. So we got the tempo right a little bit. We're getting each word as we go. Our start index needs to be fixed because we're taking up too much stuff, and the end of our string isn't being included in the result either. So good start, but let's see if we can't move on and fix this some more. So the next step is we need to separate each word properly. So instead of saying from the beginning of everything, we'll have to have some sort of index here that keeps track of where the last word ended so that we can slice it from there. So up at the top, we'll say the start equals 0. So this is just some starting value. Notice for the first word in our string, there is no previous space, so it needs to start somewhere. So we'll start at 0, and we'll make sure that that gets used when we do our slice. But now when we move on to the second word, we need to remember where the first word ended so that we can continue on. So the variable start will just keep track like a bookmark for where I was the last time we found a space. So we found a space, we slice the current word, and then we remember for the next time that we'll start where this one ended. The loop will continue incrementing the variable I until it finds the next space. At that point, we'll have the index of the previous space as well as the index of the current space, and we'll just take that next slice. So if this is the variable I at our first slice, that becomes start, and the next time I is over here, start's still there. And then at that point, we update start to here, and we shift until I is here, and then we have the slice between these 2 points. Notice that if start is equal to I, then our next slice will be from I up until the next space minus 1. So that will include the starting space. So instead of starting at I, we'll want to start at I plus 1. Save and try again. And now we got only single words. Hello everyone, this is a. But we didn't get the last word. So we're missing sentence, the very last word from our input string. So if we're only missing the last word, let's take a look at what the state of our system is at the end of our code, just before we return our result. So we've gone through this whole loop, and let's use this as our example sentence. So we found this word, which means we found this space. Okay, at that point, I was equal to whatever this index is. We took a slice from start to I, so I pointing at this space, and start, which was the previous space, plus 1. In this case, it took just a single letter slice for the word a. And then it said start equals I plus 1. So if we're at the end of our loop, this start variable still exists, and it's pointing at the beginning of the very last word. Now all we need to do is take a substring from the original string, from the point where that very last word starts, all the way to the end of our string. So we can just say, very simply, words.append a substring from start all the way to the end. Save and run our code. And we get all the words. We still have some punctuation in there, but I'm going to leave that as a homework problem. See if you can modify this code to remove common punctuations like exclamations, commas, periods, semicolons, etc. And in the next video, we'll see a way that we can solve that sub problem actually quite easily. So that's it for this video. I'll see you in the next one.